Okay, now we will move to the properties of vector space. Properties of vector space. A vector space, just a minute, sorry. First, a vector space consists of two sets of elements, basis vector psi, phi, chi, etc., and a set of scalars. Set of scalars A, B, C, and so on. And second, it obeys two rules. One is called addition rule, and the second one is called multiplication rule. Now, what is addition rule? Suppose we have two vectors psi and phi belongs to the vector space. This is the notation which I use for the vector space. Then the sum psi plus phi is also a vector, and it belongs to the same vector space. Now we will discuss different properties of addition rule. The first one is, if I add phi with psi, if I add psi with phi, the result will be the same. This is called commutative property. For example, if I consider my Cartesian coordinate system, and we have two vectors psi and phi, this is x, this is y axis. Then the sum is psi plus phi, psi and phi. The sum is psi plus phi, which also belong to the same vector space, such that if we add psi with phi, phi with psi, the result doesn't change. This is called commutative property. The second property is associative property. What it tells us? It tells us that if we have three vectors psi, phi and chi, such that if I add psi with phi first and then add the sum with chi, or if I add phi with chi and then add it with psi, the result will be the same. The third property is, for each psi there exists a vector O such that if we add vector O with psi, or if we add vector psi with O, we always get the same vector psi. This vector is called zero vector or null vector. And the fourth and the last property is, for each psi there exists a vector I such that there exists a vector minus psi such that if I add this minus psi vector with psi, or if we add psi with this minus vector psi, we get a zero vector. Then this vector is called inverse vector. Inverse vector. Now we will come to the multiplication rule. So for that I will change my paper. The multiplication rule. Now the product of a scalar with a vector. Suppose we have vectors belongs to the vector space, and such that if I multiply this vector with this scalar psi, we get another vector. I call it psi prime, such that it also belongs to the same vector space. Now if I have two vectors psi and phi, then their linear combination A of psi plus B of phi is also a vector, and it belongs to the same vector space from which we pick psi and phi. This is the first property of multiplication rule. Now if we have two vectors psi and phi such that we add them and multiply it with a scalar A, then it will be equals to A of psi plus A of phi. If we have two vectors A and two scalars A and B, we add them first and multiply the sum with this vector psi. This is equivalent to individually multiply the scalar with the vector, and this property is called distributivity with respect to addition. Now there is a third property which is called associativity. With respect to multiplication of scalars. It tells us that suppose we have two scalar A and B, or scalar and psi is a vector such that if I multiply the vector with B first and then multiply it with A, or if I multiply the two scalar first and then multiply the result, the product with psi, I will get the same result. The fourth property is for each psi there exists a vector I such that if I multiply psi with I or I with psi, I always get the same vector psi. This vector I is called unit vector. Similarly, for each psi there exists a vector 0 such that if we multiply psi with this O or O with psi, we always get the vector O. This vector O is called inverse vector with respect to multiplication. So this is all about the properties of vector space. In the next lecture we will discuss the properties of Hilbert space.